Section 1.4 are linear equations in two variables and linear functions. So when we're talking about lines, keep in mind that there are two forms of the equation of the line that we usually use. One is called the slope-intercept form, and the reason we give it this name is because when we're looking at the line, we can visually see the slope and the intercept, right? So M is slope, B is the y-intercept, or where it crosses the y-axis. The point slope formula says, well, here's x1, y1, that's our point, and the slope gets plugged into the line. So if we actually solve this equation for y, if we distribute m, solve for y, it turns into slope-intercept form. So depending on the instructions on the question that you're given on the exam, you want to make sure that if one of these two are specifically called out, that you give your final answer in the form that they want. Some people are perfectly fine with you leaving the line like this. Some instructors prefer that you simplify to this form. So I would just make sure to clarify that if it's not worded in the problem. If it's not in the instructions, sometimes either one is okay. But make sure that you get confirmation on that before you proceed with your problem. Equations of horizontal and vertical lines. So a horizontal line has a slope of 0, and the equation is of the form y equals b, right? So it's all run, no rise, meaning there's only y values, right? The same y value for every x value that you plug in. A slope of a vertical, or excuse me, an equation of a vertical line is x equals a. So it's all rise and no run, meaning that for any y value you pick, it's the same x value. Parallel and perpendicular lines, parallel lines have the exact same slope. Okay, so if we have a line with slope 2 and another line with slope -2, those lines are not parallel. So it's not the number that matters, it's also the sign in front of the number. If we have perpendicular lines, that means they form a 90-degree angle, and the slopes are related by the fact that they are negative reciprocals of each other. So you take the original slope and you flip it and multiply it by -1, and that's how we get our perpendicular slope. So let's look at an example. And it says, determine the equation satisfying the conditions stated. So the first thing is we're told a straight line passing through points -2, 1, and 4, 6. So in this particular situation, we weren't given the slope of the line, but we were given 2 points on the line. So before we can write the equation of the line, we have to calculate the slope. So the slope is the change in the y values divided by the change in the x values. So it doesn't matter which point we call 1 and 2, right, as long as we're consistent with this. So I'm going to call this point 1 and this point 2, just because this one came first. So that means my y2, right, is 6. My y1 is 1. My x2 is 4, and my x1 is -2. So when I subtract a negative number, it gets added. So a nice little visual check you can do to make sure you're doing this right is one of the things students tend to mess up, especially when they're in a hurry on an exam, is they'll tend to mix up the x's and y's in the wrong place. So if I pick the y value from this point to go first, then its corresponding x value has to go first. So one of the things I like to do to check myself is I kind of look at this in columns, and I'm like, yep, 6 and 4 should go together, right? 2 and 1 should go together. And we know that this -2 became a +2 because of the subtraction, right? So I can make sure that I've put them in the correct order. So this simplifies into 5/6. So now if I want to write the equation of the line, I can use the point slope formula, and I only need to pick one of the points. Either point I pick should give me the same line, so I'm going to pick this one just because it's first, right? So if we use the point slope formula, it says y minus y1. Our slope is 5/6 times x minus minus 2. So if you're allowed to leave the line in point slope form, you're done, right? But suppose you have to simplify it into slope-intercept form. So there's a nice little algebra trick you can do to kind of help make that easier, because if we distribute this out, we're going to get fractions, right? And you're going to have to add some whole numbers to some fractions. So one of the things I like to do is I can eliminate the fractions completely by multiplying the entire equation by the denominator of the slope. So now if I distribute this all the way across, right, because I have to do it to both sides of the equation, watch what happens. So I'll get 6y minus 6 on the right, but this 6 here cancels this 6 here. So now I just distribute the 5 on the right side. Now I've got all whole numbers to deal with. So 6y will equal 5x. I'm going to add the 6 to both sides, so I get 16. And now I'm going to divide the equation by 6. But don't draw a big line and divide by 6, because then it looks like a rational expression. What we want is we want this in slope-intercept form. So what I'm going to do is I'm dividing each piece by 6. So now I can see m is 5/6, b is 16 over 6. We wouldn't expect you to simplify that down, but I can actually see. I also know that this little algebra trick works right properly if my slope comes back in exactly the same form I started with. Part B says a straight line having slope 3/11 and passing through point -3,4. So we actually gave you the slope, so we don't need to calculate it. So now I can go straight to my point slope formula. So y minus 4 equals 3/11 times x minus 3. So once again, if we're allowed to stop here, we can stop. But if we want to get to slope-intercept form, then I would need to solve this for y. So I'm going to multiply the whole thing by 11. That gives me 11y minus 44 on the left. The 11 cancels with the 11 on the right. And so now I distribute the 3, and I get 3x plus 9. So now I'm going to add 44 to both sides and get 3x plus 53, and y is 3/11 x plus 53 over 11. So now I've got it in slope-intercept form. C says a straight line passing through point -2, 1 and is perpendicular to the line from B. So the slope in part B, was 3/11. Okay? So if I'm perpendicular, I want the negative reciprocal. So that means the second line I'm going to write, we flip the fraction upside down. That's the reciprocal. And then we multiply it by -1. Now I can use point slope again with my new point. So y minus 1 equals -11/3 times x minus -2. Once again, if I want to take this all the way to slope-intercept form, my denominator is now 3, so that's going to cancel this 3. So now I'm going to distribute on the left and get 3y minus 3, -11x minus 22. I'm going to add 3 to both sides and get -19. And then now when I divide everything by 3, once again we can see the slope came back exactly the way it started, and now I have the line that was perpendicular to the first line but passing through the new point that they wanted us to get.